So, here we go. So, the idea of the day is how do you integrate something like this? X cosine of x doesn't work with u sub. Why not?
Because it doesn't that makes it work.
Because, well, if it was cosine of x squared and an x dx, would that work with u sub?
Yes.
Yeah, because then x is sort of the derivative of x squared, right?
Yes.
All right, so the point is this then, all right? You're going to have products to integrate. It's just part of math. And you actually have two techniques to deal with that product. Now, they come from undoing two different types of derivatives. When I use the chain rule on sine cubed, I get 3 sine squared, but then I pick up a factor. So the chain rule results in a product, okay? And so if I try and integrate a product where one is the derivative of the other, u sub does that. U sub undoes the chain rule. Cool? Okay. Now here's the thing though. Yes, a product can come from chain rule, but there's another place we get a product derivative. When? What kind of derivative results in a product? I'll say it again. What kind of derivative rule results in a product?
Product.
A product rule, okay? So I get a derivative that gives a product also from the product rule. U sub doesn't undo that kind of derivative. That's what integration by parts does, all right? So this is where the idea comes from. It won't be how we're going to do it in a second, but I need to, rather than just put up the formula, that's not my style. I want you to understand why it is what it is, okay? So imagine, I took the derivative of something, and that's what resulted in that x cosine of x that I was looking at up there, okay? What could I have taken the derivative of to give me x cosine of x in the product rule? Yes?
1/2 cosine x squared.
X.
I suppose that's true, yes.
Wow.
What else?
X.
That's true, you're right, you got me there. X
Sine.
sine of x is what I'm looking at. True that, okay? I'm going to go with that. You're right, there are two possible answers to that question. This is the one I want to help me get where I want to go. If I took the derivative of x sine of x, then I would get first stays the same, derivative of the second, plus second stays the same, derivative of the first is 1, right? Do you agree with my product rule derivative?
I do.
Okay, cool. Now, the part we're interested in is that x cosine of x. So if I isolate that, then I could keep that where it's at. Actually, I'm going to write it on the left-hand side, but really I'm going to keep it where it's at so it stays positive. And that would be equivalent to if I left this side there and subtracted over. So it would be equal to the derivative of x sine of x take away a sine of x. You see what I did there? I isolated x cosine x. Okay, now the whole question of the day is how do you integrate that? So if I integrated that, I could do that as long as I did that to both sides. Okay, now I should say what I'm integrating with respect to. I'm integrating with respect to x. You follow? Now the left side is the question. I don't know what it is. But the good news is it's equivalent to the right side, and the right side's nice. First, can I integrate two parts of a difference separately? Yes? So this first part, what's the antiderivative of the derivative of x sine x?
X.
X sine x. The antiderivative of the derivative is just the thing. The antiderivative of sine of x is much easier. In fact, I could do that. It's just cosine or negative cosine. Yes?
What's going on? Why do you have derivative? Oh, yeah. Why do you have derivative x and then dx? I'm sorry.
Why is this? Why is this one here?
Yeah.
I took this same thing here and this same thing here, and I'm integrating both sides with respect to x. So I took the statement above and I'm integrating.
I think
She's asking, like, shouldn't there be a closed parentheses after the x sign of x?
Yeah, I'm like, where?
Oh, here, I see what you're saying. Yes,
Yeah.
absolutely. Sorry, my bad. Yes. Close parentheses there, yes. Okay, so the first part is just done. X sine of x is cool. Sine of x I anti-differentiate, and I get just positive cosine of x plus a c when I integrate finally. So that's all that. Now, the antiderivative of that then is really a rearranged form of the product rule with some pieces integrated. That's the idea on integration by parts. Now, I definitely don't want to do that whole thing. I'm not going to say, well, let me think of what could have been the product, and I'll integrate some stuff and move. That's tedious. Okay, so like we typically do in math, we look for trends or generalize the pattern. So let's generalize this. I wanted to integrate generally a product of two things. The whole idea is I'm looking at as a part of a product rule derivative. So we're going to identify the thing we're integrating as actually part of a product rule. Oh, shoot, that's not what I wanted to do. Will you erase that, please? Say I looked at taking the derivative of a product where u and v are functions of some variable. They could be of x, they could be of t, doesn't matter, but they're functions, and that means the derivative of product uv. That d is the general derivative with respect to whatever the variable is. Do you follow? By product rule, when I take the derivative of the product, its first stays the same, u, times the derivative of the second, dv, plus second stays the same, v, times the derivative of the first, du. I think you'll agree with the product rule, yes? Okay. Now the whole point was not to just take the derivative of a product, but to then rearrange it to isolate one of the factor terms. I'm going to isolate this guy, u dv. If I kept it by itself, and I'm actually just writing it on the left, but it's just by itself, would be the side with the duv plus, or minus rather, the v du when I move it. You follow? Okay? Now, we're trying to establish a pattern for a product to integrate. So I could then say I can integrate both sides. Integration is an operation just like addition, subtraction, multiplication. It keeps the equation balanced as long as I do it to both sides. If I do that to both sides, then the left side is all good. That's what I'm trying to make a pattern for. But the right side can be integrated separately because it's a difference. What's the first part? The antiderivative of the derivative of uv. uv minus, now this, the antiderivative of this, will be something we'll have to find. Ultraviolet voodoo is commonly used to help you remember the pattern. uv minus vdu. And the idea is you're integrating a product by using this rearranged product rule. And the idea, the big condition is that this integral you get as a result should be easier to work with than the original. All right? You're exchanging for an easier integral. Now this, we'll start off easy here, and I'm going to start by telling you, rather than having you guess what u could be or dv could be, I'm going to just tell you this time you're going to use this u and dv. All right? So here's how it works. If you're given a product, this obviously should look familiar, but now let's go about this and how you're going to do this on the homework. I typically would write the problem, and then above it, I guess I could think of it like a blueprint to which I am plugging stuff in. I'm going to write the ultraviolet pattern. u dv is u v minus v du. And it's like the old pre-algebra formula, substitute a value. Into that formula, I need to substitute all the components. Now, it feels like there's two components, but there are actually four components to this problem. There's u, And later on, you'll see that there's a du, okay? And there's dv and a v that goes with that. So after you write the problem, you decide what are those four pieces. Now I'm telling you, in this problem, as far as in the x cosine of x dx, what should u be, what should dv be? I'm telling you, let u be the x, in which case dv is all the other stuff, cosine of x dx. Now you can see the right side, I need to know u, but later on, like I said, I need to know du. So if u is x, then du is dx. You can also see that over here, I actually need v. To get v, I need to anti-differentiate. What's the antiderivative of cosine? Sine. Now, everything is there I need to plug in. uv is x sine of x minus the integral of v du is sine of x dx. The whole point being to exchange for an integral that's easier. The first part's done, leave it alone. What's the antiderivative of sine? Is it cosine or negative cosine? Negative cosine. So that negative combined with the negative that was there was going to turn it to positive cosine of x. And then like all integrals, you have a constant integration. How can I check that answer if I were so inclined? I could take the derivative, and you would see it does actually go right to x cosine of x. It would be a product rule, and one term would drop out. It would be all hunky-dory. Yes?
So for the UDU, DV, is that the only work that we have shown that?
This is, what I have here is the work I would expect to see, the four-part choices and then the formula function. Okay? Try this one on your own. And again, I am giving you what to call u and dv. Okay, so I'd ask you what's u and dv, but that's obvious, they're given to you. So u is x, dv is sine of x dx. In a true problem on the homework, those would be told to you. You would make that choice, and we'll talk about that on the back, okay? If u is x, then what's du? dx. And if dv is sine of x, then v is cosine or negative cosine? Negative cosine. All right. After you've done that part, then you plug into the formula. uv is negative x cosine of x. Minus, I suppose, that's going to go away, but I'll just go by the book. V is negative cosine of x, and du is dx. The negatives, like I said, cancel out. Hopefully, when you get this new integral, it should be easy. What's the antiderivative of cosine? So, that. How'd you do? Good?
Good.
Okay. Now, the hardest part of this is not the execution of the product of the plan when you know u and dv. The hardest part is figuring out what to make u. That is the place that leads to the most mistakes. So let me get across the big idea. If your choice leads to a worse problem, you chose badly. Okay? Let me give you one illustration to show you what bad choice will look like, and you'll know when you make that mistake, hey, I did something wrong. So we just did this problem, and when choosing well, we let u equal x and dv equal cosine of x dx. du is dx. I'm going through this quickly because we just did this. Now the idea was that when we made our substitution, x sine of x minus sine of x dx, that's easier. If this is easier integral, then that means we had a good u. If the person next to you had said, you know what, I'm gonna let this be my u. U is cosine of x. Sometimes you make a bad choice and you have to go up back and scrap it. Now, if u is cosine, then what's dv? X dx, right? Du then would be negative sine of x dx, and v would be the antiderivative of x, which is 1/2 x squared. Now, upon substitution, when I plug into the formula, uv would be fine. It's 1/2 x squared cosine of x, no problem there. But v du now is 1/2 x squared times negative sine of x dx. Well, here's the original problem, and here's now what you have to do. That's even worse. Okay? If, after your integration by parts choice, you get an integral that's worse, that is a terrible u choice. So, how do you choose u? The whole idea is that when you choose u, du is easier because du is what actually happens in the numerator. Your choice has to be such that the derivative is making your life better. This is an acronym that I use to help me choose u. The best possible u is if you see a log choice. If there's a log in there, like natural log, that's the best possible u. The next best choice is if there's an inverse trig, like arctangent or arcsine. The next best is polynomial. Now please write this down. Polynomial could include x, x squared, and such. But dx also could be considered a polynomial. You're going to need that at the bottom. All right, dx is a thing. People think dx is just extra crap that I don't even write it sometimes. I don't care. It's a big deal. Okay, big deal. The worst, these are really a tie for the worst. The worst possible u is exponential trig. First of all, if you have e to the x and then you take du, well, du is still e to the x, and it didn't go anywhere. It's still bad. And trig, if you had sine, you took the derivative, well, now it's cosine, and that's not any easier, I assume. So these are terrible u's. This actually can be used in circular integration by parts, which we don't teach in Calc 1, but you learn in Calc 2. It's where you really go around in a circle to get right back to where you started, but better. It's fun. If we have time later, we'll do it. So now we're doing an actual integration by parts problem, or ultraviolet voodoo problem that you'll get in the homework. I'm just saying, here's an integral, do it. I'm not telling you here's u. I'm not telling you integration by parts. I'm just saying, do it. Why is this not u-site? Because it's a product, but one's not the derivative of the other, right? Okay, so integration by parts is a good candidate if you see a product where one's not the derivative of the other. So I'm thinking, all right, here I go, integration by parts. To make that all go, I need to choose u and dv. Remember, in this problem is what it should be showing u and dv. So I should be identifying u is this and dv is the rest. Choose your u. What do you see? The best u is? Now natural log. And so right there is natural log. U should be natural log. dv then must be the rest of the stuff. X dx, yeah? Based on those choices, you need to differentiate and integrate. du is 1 over x dx, and v is the antiderivative of x, which is 1/2 x squared. Upon substitution, uv, and maybe a switched order, 1/2 x squared natural log of x. Cool? Minus the integral. What's the integral now? 1/2 x squared, the du is 1 over x dx. Does that integral fit the bill of being easy? Can we take a step forward? Yeah, that's easier, all right? So 1/2 x squared natural log of x minus the antiderivative of really just 1/2 x. That's doable. 1/2 x squared natural log of x. By the way, if you skip that cleanup step and just went straight to the antiderivative, I'm okay with that. What's the antiderivative of 1/2 x? 1/4 x squared. What's this? Okay. Try the next one. Off to the side. See if you get it. I don't grade for that, but I recommend it for one. So, I mean, the more you write, the more you get. So it's up to you. So what's u? We don't have log. We don't have inverse trig. We do have polynomials. So u is x. dv then is e to the x dx. Antiderivative of, or sorry, derivative of x is dx, and the antiderivative of e dx is e dx. That's nice pieces to work with. Let's see if our integral comes out better. uv x e to the x minus the integral of, what's my new integral? Oh, I got it. E to the x dx. That is easier, but sure enough, that's the idea. How'd you do? All right, these can get ugly. They're going to give you pretty nice ones like this for a while in the homework, but eventually down the line, a couple, 3 or 4 problem sets, they'll start to get a little uglier. So you have a good ugly one in your notes. Let's try one like this. This will draw both on your integration by parts, but also your u sub skills. Unfortunately, because u is in ultraviolet voodoo, I'm not going to use u sub. I'm going to use w sub, because you should never use a variable in 2 different ways. All right? So, say I'm looking at 3x sine of x dx, and I say, all right, well, one's not the derivative of the other, so it's not u sub. That's what I said, 4x. Thank you. Way to tell me early. That's good. I appreciate it. I hate it when they let you do the whole problem and then say, hey, you cut it down. Okay, so I'm using this. What's u? Well, dv is sine of 4x. Wait. du is 3 dx. Everything's going great, and then we hit a big fat wall. Now, here's where I will give you a little latitude. Some people can integrate that. I think of it as mental use of. Can anybody do that? Yeah.
It's 1/4 sine.
Cosine? The
Yeah,
negative?
negative. I did it wrong.
Okay. So if you can wrap your mind around that, then cool. With practice, you can do basically what's mental use of. It amounts to, if you're interested, this is what we go through your thought process. You'd say u is 4x, du is 4dx. I put in a 4, bounce with a 1/4. I'd integrate 1/4 sine of u, which is negative 1/4 cosine of cosine of u, and so negative 1/4 cosine of 4x. Now, if that works for you, great. If it doesn't, then let's go a little slower. Wouldn't we u sub, or actually I'm going to say w sub this. W is 4x, so dw is 4dx, so dw over 4 equals dx. After that then, it becomes the integral of sine w times dw over 4, which is negative 1/4 cosine of w, which at the end of the day is negative 1/4 cosine of 4. That's W sub on the question. You with me? Any questions, or did I make a mistake? All right. That then is ready to be plugged in. UV is negative 3/4 cosine of 4x minus V du. I suppose would turn to positive 1/4. Nope, 3/4. Am I going too fast by plugging all this in at once too quickly? Minus, I'm just going to go slowly, minus V. V is negative 1/4 cosine of 4x. Du is 3dx. Know yourself. Are you a type of person that makes silly mistakes? If so, go slowly. I definitely am. Positive 3/4 integral of cosine of 4x dx after cleaning. Yeah? With another w sub, w equals 4x. I feel like that's okay because w is the same. dw is 4dx. 1/4 dw is dx. So with substitution, I get negative 3/4 cosine of 4x plus 3/4 cosine w times 1/4 dw. Man, I'm getting tired. Negative 3/4 cosine of 4x plus 3/16 sine of w, and w is 4x. So my final answer, negative 3/4 cosine of 4x plus 3/16 sine of 4x plus c. Yes.
Okay, so if you didn't, I'm trying to do this. If you didn't need to do the W sub, could you just go straight to that?
Yep. You can avoid the w sub if you can do that, but yes.
Shouldn't it be negative 3/4 x because u equals 3x?
I believe you're right. UV, I should have an X in there. I agree. Yes, you're right, Brian. Sorry. Did y'all get that same thing? You're right. Okay. All right. The most dangerous ones are the ones that don't look like integration by parts. I guarantee this is the age-old calculus effect. Okay, I can tell you calculus teachers from all over the world will put this problem on their exam, and they will make choice A. What do you reckon they'll make choice A? 1 over x. And more than 50% of the people will 100% choose that. You better believe it. Why is that not okay?
That's wrong.
Yeah, that would be the derivative of natural law. Does this mean take the derivative? No, it means take the antiderivative. So that is a big fat no. And yet, people say, well, what am I supposed to do? It's not a product. Well, it is a product because dx is a thing. Okay? Dx is not nothing, it's something. And it is a product. U v minus v du. What's u? Natural log of x. What's dv? dx. What's du? 1 over x dx. And what's v? X. Okay. So upon substitution, uv is x natural log of x. I prefer to write the x in front of the natural log instead of behind. It tends to bleed into the argument of the natural log otherwise. Minus v du is x times 1 over x dx. That's nice. What's the antiderivative of 1? X plus c. Right? Same goes with arctangent. It's a product. To integrate arctangent, you must use ultraviolet voodoo. What's u? Arctangent. Okay, now. dv then is dx. Okay. Not that you guys would ever do something so silly, but this will happen all the time. I'll see people say, well, u is arctangent and dv is x dx. Yeah? No? Why not? X is the arctangent. You're saying I can't separate x from the arctangent? That's correct. You cannot. Okay, this, I know you'll think, well, I don't know, what's the point? To me, when you do this, it's like if you were saying this, I'm going to do this by ultraviolet voodoo, and I'm going to let u equal the root sign and dv equal the x dx. What? You can't do, that's an operation. What are you doing? It has to be the arctangent of something. This is not just an x. It must be the arctangent of x, obviously. So, what is du? 1 over 1 plus x squared, and dv, if dv is dx, then v is 1x. Okay, so you'll see then that the integral, although not easy, is easier. uv is x arctangent of x minus voodoo. The integral of voodoo is x dx over 1 plus x squared. How do you reckon we should attack that bad boy? W substitution. Some could do this mentally. What's your W? 1 plus x squared. What's dw? 2x dx. Therefore, x dx is dw over 2. And upon substitution, I get 1/2 dw in the top over u in the bottom. W dw. Can't get over u sub. What's the antiderivative of 1/2 1 over w? 1/2 natural log of the absolute value of w. All said then, with substitution, that's 1/2 natural log of the absolute value of x squared plus 1. That whole thing was there the whole time, x arctangent of x. Don't forget your c. Be wary of log rules. Say you did it that way and you're confident, and yet in the back of the book, they have this. Did you do the problem correctly? Yeah. If you brought that 1/2 up as an exponent. Furthermore, would this absolute value even be necessary? What if they had this answer with 1/2 but no absolute value? Would that be okay? Why?
because x squared is always positive.
X squared plus 1 is positive. You made that. Yeah, so that would be better. Yes.
Do you have to keep the way that they formatted the arctan, or could you write TGK?
That's fine. Both notations are accepted. Okay? All right. Do you feel like you get it? Or do you want to try the arc sine one? Try it. It's not pretty inside. You need to try it. Ugly. How'd you do? X arc sine of x minus square root of 1 minus x squared plus c? Do you agree?
Yes.
Okay. Alrighty then. A u sub nested within an integration by parts w fine. That is that. Questions on 60? I thought the other class, which admittedly is a bunch of weasels, said we did not get through 67, and I did not say they had to turn it in. I feel like that's a lie.
You told us we had to.
I told you you had to turn it in. So we're done with 67 questions in your class, yes? Good. I said you could turn it in today, which I was grade test, so that's fine. 68. Can I get 68 questions then, please? What? One.
I have a really quick question
Sure.
about how much I'm gonna fill in this. If you just gave us halfway through, how many points do you have?
It depends on whether I check it or not. If I see it, which of course now I will be looking for, it will be -1 for every one you list on.
I always write that I gave up.
So this might be a good time to pause and remind you of how I grade homework this way. If I see a blank box, that obviously is -1 out of 10. If I am checking a problem and I see you list out, for example, I helped you and I said, you got it from there, and then you just said, okay, and then you just left it, that also would be -1. If you do the problem all the way through incorrectly, and your mistake made the problem considerably easier, then I also count off 1. You don't get a pay, there's no payoff for being done, okay? If your mistake made the problem harder and you missed it, then fine, I'm fine with that, good job, okay? If you just basically did the problem wrong and there is no major difference in work, I'm okay with that. If you did the problem wrong, you have no idea what you're doing, and yet magically the right answer appears at the bottom because I'm giving you all the answers, that to me is plagiarism. I absolutely count off a point for that. Okay? Understood? All right. 24? All right.
Struggled on this.
124. Okay, set 68, number 1.
I couldn't find my graph.
Do you have, I assume the issue on number 1 was building the cost function, is that correct?
Yes.
Okay, that is the hardest part of the problem. So, the way I understood this, the top, bottom, and the sides, first of all, it's square bottom. Did you call these X and X, or?
Yes.
All right. So, they give you that the volume, which is obviously X squared Y, needs to be in 300 cubic units, whatever they are, cubic meters. And then they give you a bunch of stuff about the conditions of the top and the bottom. The material they use for the base, let the height express the total cost. So question A is total cost. Now, students want to make this a surface area problem, and in some sense it does absolutely have to do with surface area, but that's not all. You're not minimizing surface area because that doesn't take into account the different prices of the components. There's more, okay? So this problem to me is overload, and I took a huge step forward when I broke it into simple pieces. I need the top cost, the cost of the top, the cost of the bottom, and the cost of the sides. I wish I was smart enough to just zoom into the equation with it. I need to develop it. All right. Now the cost of the top, they tell me that the top, the roof is $4 per square meter. Well, I couldn't obviously put $4 per square meter here because that wouldn't be cost. That would be dollars per square meter, not dollars. So what else do I need to take into account? $4 per square meter times how many square meters? Okay, I would need the cost per square meter and the number of square meters, which in this case is X squared. By the same token, the bottom is $8 per square meter. You can see then the area, the meters would cancel out and I get money, which is the goal. Okay, the bottom is $8 per square meter, and it also is X squared square meters. The square meters cancel and I get money. The sides are, the walls are $15 per square meter. And I would then multiply that by how many square meters? How many square meters to the sides? XY per side times 4, right? So 4XY square meters cancel. If you feel like I do that the units help you, then use them. If you feel like it makes it more complicated, then don't use them. This isn't science. I'm not picky about that. They help me. So simplified then, without the units, I get 4x squared plus 8x squared plus 60xy, or 12x squared plus 60xy. I suppose I could factor out next, but I don't know if that helps me with 12. Part B then, as you might imagine, is before we differentiate to minimize costs, we want to get it down to two variables. So, oh no, this is still part A. So what can I sub in for B, for Y? Yeah, volume, which is 300, is X squared Y. So that implies that Y is 300 over X squared. If I substitute that in, then cost is 12x squared plus 60x times 300 over x squared, or in its simplest possible form, 12x squared plus 18,000 x to the negative 1. Cool? That to me is the hardest part. Do you want to continue on with the calculus, or you good?
Yeah, when I put it on my graph, when I did the derivative,
Yeah.
my graph was super big. It didn't have.
I imagine so with the magnitude of that, yeah.
But it didn't zero.
It never had I could tell, so again, this is old school graphic, but I worked without a calculator, a graphing calculator so long, but I know that this is a parabola with an asymptote. So it probably will look like this. I imagine it should have a minimum. If you're not sure, then you could continuously zoom out, or you could just go ahead to the calculus and then go back to the calculator and get a feel for what the number is. Let's do the calculus. If I find C prime, it's 24x minus 18,000 over x squared, which is 24x cubed minus 18,000 over the common denominator x squared. Obviously, this would be undefined at x equals 0, but in terms of the dimension of the cage, that's not happening. So I will ignore that critical number and instead focus on 24x cubed minus 18,000 equals 0 at 18,000 divided by 24 cube rooted. Or I suppose the cube root of 4,000. What else? I guess I could have taken out more. Oh well, 4,000. What is my problem? I'm taking out 6,000, so 3,000. So I'm taking out 6, W. Sorry. 1,500, 725 cube rooted. So I would imagine just shy of 9. Just barely less than 9. Right? I don't know if that's right, but it seems right.
What's the cube root of 750?
750. 1,500, 750. So a little more than 9. Yeah, 9, a little more. That is a max, by the way, or a min, rather. The derivative goes negative to positive there. C prime goes negative to positive, so I can be sure that's it. All right, 24. Does that make pretty much sense? Did you figure out then what the window issue was? Or?
I just did that, and that makes more sense than trying that.
Okay, yeah,
Handle it.
yeah, especially considering the derivative is so clean, I do that first. Okay.
Yeah. 6 or something like that.
So what if you trace? I found on the Inspire, if you hit trace, then the window automatically starts to adjust to where you're
Isn't
looking
there
on.
one where it's like big to graph?
Is there a zoom fit or something? So it doesn't do
It does that.
Oh. So if you hit side to side, if you hit trace and then go side to side, I was just looking side to side, but you're right, it's still not. It's
Like
taking
7,000.
Yeah, you're right, it's not.
And it's thinking a lot.
Yeah. So, I don't know, if somebody, yes?
This is a related question, it's just looking at the question.
Sure.
So if f prime of x equals like a constant, do you have any like if I'm trying to find extreme values here, would there be any critical numbers?
You could, there are no critical numbers.
No, yeah, that's right.
There would be no critical numbers in the mid, the extrema would have to be the infinite line.
All right.
Okay, you bet. All right, number 24. 24 is, did I hear right in 24, by the way? Is that
Yeah.
replaced in some fashion? It's replaced. Oh, no, it isn't. I thought it was replaced, but it's not. Okay. This is actually, they're trying to prepare you for exponential derivatives, which is probably going to be right at the start of next semester. It's early 70s. As an exponential whose base is e. So they want 2 to the x as e to the question mark is really what they want you to do. So forget the y, for example, and translate it to that. E to 2x is e to something else. How would you solve that? For, I suppose we need question mark. How'd you solve that for question mark? Yeah, we could natural log both sides. Natural log of 2 to the x equals natural log of e to the question mark. Tells you question mark is natural log of 2 to the x. maybe I don't even need the x. Maybe I just need the 2 is e to what power, right? Do I even need the x in there, or can I just say, how can I rewrite 2 as e to a power? Maybe I should blow off the...
Good morning, Douglas Jaguar. Please rise for the Pledge of Allegiance.
So,
Ready? Begin. I
pledge allegiance
to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
so yeah, I guess this would be e to the natural log of 2
Tomorrow, yeah, next
for
Friday,
the x,
we'll be making
which is most definitely the same as 2 to the x. Guess that fits the bill?
We would love to have you on this first Friday when we come back next semester.
That's
There is a
weird.
secret Santa happening starting today until December 13th. Pick up a slip of paper with a name and then enter your name at once. You can give a gift and get
You might be saying, why would they do that? Because that's what would allow you to take the derivative.
Honor Society meeting on Friday during the 7th hour in the auditorium, and all members are expected to be there. If you have a conflict,
Is that
Don't
really?
miss the 24th annual Holiday Food Hall Project. Friday in the auditorium for the after school with Brady Cross and 7 o'clock for competitive lacrosse. Each show costs only $3 to see of all the kids all the rinks. Don't miss out.
and then tomorrow's the last opportunity to bring in your used book and give your homework.
Do you want to serve on a focus group to have in home or hiring on our new book? Stop by the library and let me order and that's the class if you're interested.
If you would like to volunteer to be a swim buddy on Saturday morning to help children with special needs, that's what